Okay, for question 12a, they give you wire P and wire Q with a diagram. The distance apart is 2 centimeter here, and then wire P carries a current 7 ampere to the right. Point C 3 centimeter from wire Q and in the same plane as wire P and Q. Determine the magnitude and the direction of current in wire Q so that the magnetic field at C is equals to 0. So they want to find the direction of the current and the magnitude of the current so that magnetic field over here is equals to 0. So you already have the direction for P, right? So you can determine the direction of magnetic field due to wire P first. Okay, use right hand grip rule. Point your fingers, your thumb in the direction of current there, and at the point C it will be into the page. So this is a magnetic field due to wire P. So obviously if I want to find magnetic field so that it is 0 at point C, I need to have another magnetic field going out of the page. So that one will be due to wire Q. So to determine the direction of current, okay, delete this one first. So to determine the direction of current, put your thumb, okay, on the wire Q, and you basically want to have your fingers or your magnetic field going out of the page, so it looks something like this. So this one is going out of the page, this is pointing to the left, so direction of current will be to the left. So you already determined the direction of current. Now you just have to find the magnitude of that particular current. Okay, we can start with summation of B is equals to 0, where B in minus B out is equals to 0. So B out minus B in equals to 0. So maybe I can write BQ minus BP equals to 0, which is equals to, let's bring to the other side straight away. So long straight wire, the equation is mu naught I over 2 pi r. So it will be mu naught I for Q equals to 2 pi r for Q. And then over here we have mu naught I for P over 2 pi r for P. You can cancel out mu naught first and then 2 pi. So IQ is the one that we want to find, but we do have the values for the distance there. It is 3 centimeter from wire Q, right? So the R is 3 centimeter. Okay, if you want to change to SI unit, and then IP is equals to 7 divided by 0.05, because you have to add 2 centimeter and 3 centimeter there, because it should be the distance from the wire to that particular point. Okay, so just have to press your calculator. I got here is 4.2 ampere. So the magnitude of wire Q is 4.2 ampere, and the direction, as we already determined just now, will be to the left. Direction of current should be to the left. Okay, for question 12b, it says that a copper rod of mass 0.08 kg and a length of 0.2 meter is attached to two thin current carrying wires. Okay, the rod is perpendicular to a uniform magnetic field, and they ask you to determine the magnitude and direction of electric current to keep the copper rod fixed and stay horizontal. So you can imagine the rod here is basically hanging, like it is a floating, okay, and it has a weight. So you can expect that the direction of the weight will be pointing downwards as always. So if you want to keep the rod floating, that means you need to have another force that is going upwards. So this is the magnetic field force. So they ask you to determine the magnitude and the direction. So if you want to determine the direction first, okay, because this one we are talking about force, we can use palm rule. So you point your fingers, the 4 fingers that represent the direction of magnetic field. In this case, magnetic field is into the page, so into the page. And then your thumb is pointing to the right. I mean, if you want the force to be upwards, your palm need to be upwards, so your thumb will be pointing to the right. So your thumb is actually the direction of current itself. Okay, so just bring this one, just put this one over here. Okay, remember that the direction of magnetic field is using your fingers there, so that one is into the page. Your force, which is upwards, is your palm, because this one is a current, so we want to use the positive one, tampak ke depan. So your current is pointing towards the thumb, sorry, your thumb is pointing towards the current. Okay, so now you just have to find the magnitude, and then you can write down that the current is flowing to the right. Okay, so if you have balance of force, so summation of force is equals to 0. F net equals to 0 lah. So we have F minus weight equals to 0. So weight is equals to mg. I bring it to the right hand side. And since we are talking about straight conductor, the force would be BIL sine theta. And since the angle between the current and the magnetic field is 90 degrees, current to the right, magnetic field into the page, so this is your current, right? So this is magnetic field, the angle is 90 degrees there. So sine theta equals to sine 90, which is equals to 1. Okay, they want to find current, so I can write down mg divided by BL. So mass here is 0.08, 9.81. Magnetic field is 0.6, and length is 0.2. So I got here current is equals to 6.54 ampere. And the direction will be to the right.